fundamentals. I'm going to pass this over to Elliot here.
All right.
Go over some load cell basics.
All right. So the load cell fundamentals. Essentially, you're going to use the load cell in one of two ways: either in a bipolar, like for universal application, or be using it both in tension and compression, or in a single mode, either only tension or only compression, and that's going to dictate what output you get from the load cell. Most of our load cells are going to be a tension upscale device, meaning you're going to get a positive output when a load cell is placed in tension. And so also correlate with your calibration certificate as previously referenced. Standard output from the vast majority of our load cells is going to be an unamplified millivolt to volt ratiometric signal. We'll come back and hit that again a little bit here. We do have amplified signals available as well. Oftentimes customers will require that to interface with their data acquisition units. Some examples of amplified unipolar signals would be a 0 to 5 volt output, or a 0 to 10 volt, or a 4 to 20 signal. Examples of bipolar amplified outputs would be plus or minus 5 volts, plus or minus 10 volts, and in some instances 12 plus or minus 8 milliamps. Again, the unamplified output is going to be a ratiometric millivolt to volt output, and we got some examples on the next slide here. All right, so in this example, we've got a 5,000-pound load cell connected to an instrument of some kind. In this case, this is our 9840, and then we have a load placed on the load cell. So again, we're going to assume a nominal output of 4 millivolts per volt, and assuming 10 volts of excitation, that means at full scale with 5,000 pounds on the load cell, you would see a nominal output of 40 millivolts at 5,000 pounds. A variation of this would be if we only supplied 5 volts of excitation, we would expect half of the output, or 20 millivolts at 5,000 pounds.